So today we're going to continue on with making triangles congruent. You'll remember that on Friday we talked about making triangles congruent with angle, side, 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 and angle, side. But we said we were going to wait till today to talk about hypotenuse leg. We talked briefly about hypotenuse leg a few days ago when we talked about how hypotenuse leg is its own special circumstance because you don't have a hypotenuse and leg in a triangle if your triangle is not a right triangle. And you will see that that's exactly what's being mentioned here, that you have to have a right triangle in order to prove that your triangles are congruent by hypotenuse leg. So in this case, we're going to talk about a proof where we use hypotenuse leg, and we are going to have to use this reason right here to show that we have a right triangle before we can talk about hypotenuse leg. So I'm going to have you put hypotenuse leg out of your mind for a second, and I'm going to work through this proof like you would if you didn't know it was hypotenuse leg. So if we're working through this proof, we would take a look at our first given. This should say given, I think, and it doesn't. We would take a look at our first given, and the first given tells us that we have perpendicular lines. And if we look at where BD and AC are perpendicular, we can see that there are right angles that are here and here. So we know, based on what we had done previously, that if we have perpendicular lines, we have right angles, and the best way to name those right angles is going to be to put numbers on them and call them angles 1 and 2. So in my proof, I'm going to put in here that I know that angle 1 is a right angle, and I know that angle 2 is a right angle because perpendiculars form right angles. And then if we were doing what we normally do, we would continue on, and in our next step, we would say, oh, we know that all right angles are congruent. So I would put angle 1 congruent to angle 2. All right angles are congruent. And I might even go so far as to put an A in front of this to say that now I have a set of angles. And then we would continue on, and we would look at our second given. This is exactly what we've already done, so I'm not doing anything new here. And when I look at my second given, which tells me that AB and CB are congruent, I would say that's just great. That's a set of sides between the triangles. When I run out of givens, I turn to my picture and I say, what am I supposed to notice in my picture about what it is that's going on? And when I look at my picture, I can see that there's a shared side. And we talked on Friday about how you're supposed to be able to recognize those shared sides. And we would put in our proof that BD is congruent to BD. And we would put reflexive. And then we would say, oh, this is just great. Now we have another set of sides that are congruent. And I've gathered up my 1, 2, 3 pieces of information. And now I can say, oh, my triangles must be congruent. Let's go back and see why they're congruent. And as soon as you start looking at why they're congruent, you are going to notice that the reason why they're congruent is not a reason that's acceptable. So our reason as to why these are congruent is that it looks like angle side, side. We have 2 sides and an angle, but the angle is not between the 2 sides. So what we talked about a couple days ago, last week, was whenever it's angle side, side, if we know that that's not a legitimate reason, we ask ourselves the question, is there a right triangle in the picture? Actually, 2 of them. And in our picture, we know that both of those triangles are right triangles because they have right angles in them. And if it is a right triangle, then we say, do we have a hypotenuse congruent to a hypotenuse? And for our situation, what we see here, the red sides would really be hypotenuse congruent to hypotenuse because both of the red sides are across from the right angle. So instead of these red sides just being sides, they're going to be now named specifically the hypotenuse of each of those right triangles. And if I continue on, if I'm using hypotenuse leg, I also have to have a leg congruent to a leg. Do I have that? In this case, yes, I do. It's the shared side. So this shared side isn't just a set of sides. It's more particularly now a leg congruent to a leg. So I'm now recognizing that this triangle proof is really going to be a hypotenuse leg problem. But I have to go back. This is part of my job to remember. I have to remember to go back and make sure I write in my proof that these are actually right triangles. So in my proof, I have hypotenuse congruent to hypotenuse, and I have leg congruent to leg, but I do need to go one step further, and in my proof say that I have right triangles. So I'm going to say that triangle ABD is a right triangle. Not right angle, but right triangle. And triangle CBD is a right triangle. And the reason why I know that is because a right triangle has one right angle. So in this case, the one right angle for each of those triangles was identified back here in line 2. Both of the triangles have a right angle identified. And as soon as I know that I have right triangles, and I have hypotenuse congruent to hypotenuse and leg congruent to leg, now I can say in my proof that triangle ABD is congruent to triangle CBD. And my reason is hypotenuse leg congruent to hypotenuse leg. Very specific proof. You have to make sure that you are identifying right triangles, not right angles, right triangles, before you use hypotenuse leg. In the next example, we have talked about the new reason that we're going to use, but we haven't actually seen it necessarily written down. So in this next example, we are going to be using a reason called corresponding parts of congruent triangles are congruent. And with this reason, what it means is once your triangles are congruent by your 3 parts that will make congruent triangles, you automatically know, once the triangles are congruent, that the other 3 parts have to be congruent as well. So if you take a look at this example that you see here in question 2, it's telling you to prove that CR and BR are congruent. What we're going to have to do before we prove that CR and BR are congruent, those are sides of 2 triangles, is we're going to have to make triangle CAR congruent to triangle BAR. So what happens is your proof line is going to end up either having segments congruent or angles congruent, and you're going to need to know that before you can make those corresponding parts congruent, your number 1 job is really going to be to make the triangles congruent. So we're essentially just making triangles congruent, which you've been doing right along. In the first given, when we start this proof, we see that we have perpendicular lines, and we know that perpendicular lines form right angles. So if I look at where these 2 lines are perpendicular, AR and CB, I can see that I have 2 right angles that are formed. I'm going to need to identify those right angles in the proof and then make them congruent. My reason why I know I have right angles is perpendicular lines form right angles. And then once I know that I have right angles, I'm going to set them congruent to each other. All right angles are congruent. And at this point, I'm also going to put an A in front of this to indicate that I know I have one set of angles congruent. Just because we have right angles and therefore right triangles does not mean that we're using hypotenuse leg. It's only hypotenuse leg if we appear to get the angle side-side pattern. For the second given in this proof, it is telling me that I have an angle that's getting bisected. Remember, it's what comes after the word bisect. So this angle up here is getting bisected by segment AR, which means that these 2 smaller angles are congruent. I'm going to call them angle 3 and angle 4. So my bisector in my second given tells me that angle 3 is congruent to angle 4 because an angle bisector divides an angle into two congruent angles. So this gives me a set of angles. And I am currently out of given information. As soon as I'm out of given information, I need to look at my picture. And generally what I'm looking for at this point is either something that's reflexive, a side or an angle, or vertical angles, which are formed by two lines forming an X in your picture. So some of you are probably already recognizing the fact that in this, we do have a shared side right here. This has come up numerous times, so you're very comfortable with this now. So in my proof, I have AR congruent to AR, and that is reflexive. I'm going to mark that as a set of sides. I've gathered up three pieces of information. If I look at my picture, I can see that I have a side between two angles in each of those triangles. This is enough information to make my two triangles congruent to each other. So my line 6 here is going to be that the two triangles CAR and BAR are congruent to each other. And my reason, from looking at the picture and the way that it's colored, angle side angle congruent to angle side angle. Once I know that the triangles are congruent, please keep in mind that triangles have 6 parts. If I used 3 of those parts to make the triangles congruent, there are 3 parts that are left over. Once you get the triangles congruent, it automatically follows that the other parts that are left over that we didn't use automatically fall into place and are congruent to each other. So now that we know that our two triangles up here, the left and the right one, are congruent to each other, we can say that the prove line, what they asked us to prove, that these two segments were congruent, the ones I put dots on, once the triangles are congruent, in one step it falls into place that I can put in here that CR is now congruent to BR because of the reason that we talked about up here. Anytime you have corresponding parts of congruent triangles, all of those parts are going to be congruent as well. So once the triangles are congruent, every bunch of parts are going to be congruent as well. And then we're done with our proof. So what you want to remember here is that you may have a prove line that says that you have to make segments or angles congruent. You can't do that until you acknowledge your first step, which is going to be to make the triangles congruent. Okay, question 3. In question 3, we are being asked to prove angles congruent. Please remember what we just talked about. If we're being asked to make angles congruent, which is angle DAE and angle BCE, these two angles, then it is probably a good assumption to think that we're going to have to make triangles congruent first. So I'm going to erase those two angles that I just identified, and I'm going to use my normal way of marking these corresponding parts ones with little dots on them. And in this proof, what we're going to want to do before we get those angles congruent is we're going to want to get triangles congruent. And there's numerous triangles here, but the triangles that I'm going to want to get congruent are going to be the ones that I call the bow tie triangles. And I'll shade those for you in just a second. So the triangles that I'm looking at to get congruent are going to be this one and this one. And eventually you'll have to make your own decision about which triangles, but for right now, we're pretty comfortable with telling you that. So I'm going to take that shading off of there now that you see what we're working on. We're going to make triangles congruent. So for me, one of the first things that I happen to notice is that those two triangles are formed by an X. There's this crisscross through the middle with the diagonals that make an X. which tells me that these two angles are congruent. I'm going to call them 1 and 2 because they're vertical angles and they just happen to fall in those triangles that we're working with. So I'm going to put in my proof that angle 1 is congruent to angle 2 because vertical angles are congruent. So I just happen to notice that first. Maybe you'll have this in your proof in a later line, but I happen to notice that right away. So I'm going to put that in my proof. It kind of helps me because automatically now I know I have a set of angles congruent. So one of my 3 pieces of information is already met. When I move on to my givens, there's 2 different givens that are here, and both of them involve segment bisectors, which make midpoints. The first one says that segment AC is bisecting BD. So when you have it written that way, what that means is that this segment is the one that's getting the midpoint. So if I'm looking at segment BD, where AC crosses it, which is at point E, tells me that E is going to be the midpoint of BD. So I'm going to go to line 3 and say that E is the midpoint of BD. But I want you, while we're here, to also take a look at the second given. And in the second given, you're going to see that it says that BD also bisects AC. So this is reciprocated. Sometimes only one of the segments gets a midpoint. In this case, those 2 segments are actually bisecting each other. So this point E is also the midpoint of segment AC. So E is also the midpoint of segment AC. And when I write my reason for that, what I'm going to write is what I know that a segment bisector does, and that is that a segment bisector is going to create a midpoint. We know that. We've already talked in detail about how a segment bisector will be crossing a segment at its midpoint. So if I look at what I have in line 3, the first fact that E is the midpoint of the segment that goes from B to D, what that means then is that E is going to divide BD into 2 congruent parts, and those are the 2 congruent parts that we're going to have. So in line 4, I'm going to put that BE is congruent to DE because a midpoint divides a segment into 2 congruent segments. But I also have another midpoint that's listed in line 3, and the other midpoint is that E is also the midpoint of the segment that goes from A to C. So I have 2 other little parts that are congruent to each other, and I'm going to write that in the same statement because it's for the same reason. The midpoint gave me those 2 sides congruent to each other. So if I take a look now at what I really have, I have angles 1 and 2 congruent to each other. That's a set of angles. And then in line 4, I have a set of sides with the pink ones and a set of sides with the purple ones, which means I really have 3 pieces of information. And now I can say that those triangles are actually congruent. So when I write in my proof that those triangles are congruent, I'm going to put triangle DAE is congruent to triangle BCE. And my reason for why they're congruent is side angle side. Congruent to side angle side, there is 1 set of angles between the sides for each triangle. And then I go back and remember why I wanted the triangles congruent. Well, I wanted the triangles congruent because I needed to make those angles congruent. Remember the ones with the dots on them? So I used 3 pieces of information to make the triangles congruent. Once the triangles are congruent, all the other parts fall into place and are congruent as well. So because those are angles inside the triangles, angle DAE will be congruent to angle BCE, simply because they are corresponding parts of congruent triangles, so they are congruent. Corresponding parts of congruent triangles are congruent. Once the triangles are congruent, all of their parts are.